How's it going, guys? Today I'm going to be showing you how to determine if one string is a valid anagram of another string. So our problem description says, given two strings s and t, write a function to determine if t is an anagram of s. So as an example, if we're given the string s here, which says anagram, and t, which is the rearranged letters of anagram, we see that it is an anagram. So an anagram is really just taking the letters of one string and rearranging them in a different order. So as a second example, the string s, which contains rat, and t, which contains car, are not anagrams, because car is not a rearrangement of the characters inside the string rat. So the intuition in this problem is we basically just need to understand that to determine if one string is an anagram of another string, it really just matters whether or not they have the same number of each character. So essentially, here we see that a occurs 3 times. And in the subsequent string t, a also occurs 3 times. If we have this check for every unique character in s, and they have the same count in s and t, then they are actually anagrams. So if we scroll down here to the code, now that we know the intuition, we can actually start creating a solution. So the first thing we could probably determine is that if the two strings aren't the same length, then there's no possible way they can be anagrams of each other. So our first check can just say if s.length is not equal to t.length, we can just return false. So if we've reached now line 7 in our code, s and t definitely have the same length, so now we need to create our algorithm to actually determine if they are anagrams of each other. So the first thing that we can do is we can just have an array that will hold the count of each unique character that we see in s and in t. So if we pay attention here, it says you may assume that the string contains only lowercase alphabets. So this means that we can only possibly deal with 26 different characters because that's how big the alphabet is. So we can make an integer array called counts, and it'll have size 26. So the first index in this array will correspond to the number of lowercase a's that we see in S, and so on and so forth for B, C, D, so on and so forth throughout the whole alphabet. So what we can do is we can go through S, and we could actually increment, every time we see an A, we can increment the 0th index of counts. And then every time we see another letter, we increment its corresponding index and counts. We can then go through T and decrement each of those characters that we see in those corresponding indices. So at the end of this loop, which we're going to be going through, if the entire array counts contains zeros, then we know that these two strings are anagrams of each other. Because every time we saw a character in S, we incremented the value at the corresponding index. And every time we saw that same character in T, we took away 1 from that value in the corresponding index and counts. So now that we also know that S and T have the same length, we can create a for loop, I equals 0 while I is less than, and then we could just pick one, S or T, because they're the same length. We'll say I plus plus. And now we could say counts of s.char at I, and then we can actually subtract the character a from it, and we'll say plus plus. So subtracting the character a will basically just get us back to a 0-based index where the letter a is 0. So if we flip over to the ASCII table here that I have up, you'll see that a is the ASCII value 97. So if we have the letter a, so if we're currently at the letter a, s.char at I is equal to the character a, and we subtract an a, we'll just get a 0 basically. So then if we're at a b, and we subtract an a, we'll get 1. So this is basically just going to allow us to have the correct indexes into counts, just using the characters. So like we said, if we see a specific character in S, we're going to increment the corresponding index and counts. And now, because they're the same length, right, S and T, we can do the same thing in the same loop, except for T, we're going to decrement whatever character that we see. So now once this loop has terminated, our counts array is going to have something that looks like this. Maybe A has occurred twice, meaning A has occurred 2 more times in S than it has in T. B is 0, C is 0, so on and so forth. So now all we actually have to do is we just need to make sure that counts contains all zeros. And if counts contains all zeros, that means that there were the same number of occurrences of every single letter in the string S and the string T. Therefore, we can say that they are anagrams. So now we're just going to use a for each loop, and we're going to check if I is not equal to 0, we're going to return false, because that means that there are two different occurrences of a specific letter in S and in T. However, if we get through this entire loop, we can simply return true, because that means that there were the same number of characters for each specific character in S and in T. So let's see if this works. Cool. And if we pop over here to the details, we can see that we passed 34 out of 34 test cases, and our code ran in the 50th percentile. So that's how you check if a string is a valid anagram of another string in Java.